let's go deeper into the general concepts of OOP. Encapsulation. Encapsulation is one of the fundamental concepts in object-oriented programming. It describes the idea of wrapping data and methods that work on data within one unit. This concept is often used to hide the internal state representation of an object from the outside. Abstraction. Abstraction refers to the act of representing important and special features without including the background details or explanation about that feature. Let's understand this by looking into a real-life example. You go to an ATM, insert your card, give your credentials, and suppose you are withdrawing an amount. You give the required credentials and the amount is withdrawn. You are not revealed what is the process that is internally happening. That is hidden. The only required information is given to you, inserting the card, giving your credentials and processing the task. Same as abstraction that is doing to your classes as well. You can abstract the details within your classes. The next concept is class. A class in C++ is the building block that leads to object-oriented programming. It's a user-defined data type which holds its own data members and member functions, which can be accessed and used by creating an instance of that class. A C++ class is like a blueprint for an object. For example, consider the class of cars. There are many cars with different names and brands, but all of them will share some common properties like all of them will have 4 wheels, speed limit, mileage, range, etc. So here, car is the class and wheel, speed limits, mileage are their properties. An object is an instance of a class. When a class is defined, no memory is allocated, but when it is instantiated, memory is allocated. We will implement a class, create an object to it through a program. Let's write a program to create a class and instantiate it by creating an object to it. So first we have to create a class. For this, use the keyword class. Then specify your class name. Let me name it as test. Enclose the elements of your class within brackets and terminate it with a semicolon. So this is much similar to your structures in C. So this is how you create your class. Now you can add elements to the class. You can add variables as well as functions to your class. So let me use a variable A which is of type int. So the variables that you include inside a class is referred to as the data members. And I'm going to include a function as well. Let me write a function display. The functions that you include inside a class is called as the member function. So I have a data member A which is of type int and I have a member function display inside the class. Now you do not initialize the data members inside a class. You can do the same inside your functions. So let me write the body of my function here. Let's say you are initializing the data member. Let's say A equal to 10 and let me print the same. So C out, let's say A equal to, then you're printing the value of A. So this is how you create your class. Use the keyword class, specify your class name, include the members within the brackets and terminate it with a semicolon. Now, the variables that you include inside your class is referred to as the data members, and the functions that you use inside your class is called as the member functions. Do not initialize the data members directly here. You can do the same inside the member functions. Now you have created your class. Now I can say that I have wrapped together my data members and member functions, or I can say I have encapsulated the data members and member functions to a single unit, my class test. Now you have to specify the access specifiers for the members of your class, because access specifiers will pose some restrictions to the accessibility of your data, thereby providing security. Access specifiers are of three types: public, private, and protected. Protected access specifiers we will discuss when we do the inheritance topic. Now we'll see about private and public access specifiers. We will begin with public access specifier. So how to specify the access specifier? I'm using the access specifier public. So use the keyword public and use a colon. So whatever entities that comes below this will be having the access specifier as public. So my data member A as well as the member function display are having the access specifier public. Public access specifier means that it is giving accessibility to the data inside the class as well as outside of your class. Let's see how this is working. So to access the elements of your class, you need to create an object to the class and instantiate your class. So how to create an object? To create an object, specify your class name and then use a variable. So here I can say that obj is an object to my class test. So through this object, I can access the members of the class. So how to access? Suppose you want to access your member function. So specify your object name. Here my object name is obj. Use a dot operator, then specify the member of the class that you're trying to access. So let me call the display function. So when I say obj.display, I'm trying to call or access the display member function of my class test. Let's verify this. Let's check whether you're able to call the function display. So what is your display function doing? It is initializing your data member A to 10 and it is printing the content of your variable A. So your output should be like A equal to 10. Let's build and run and check. Yes, you can see your output A equal to 10. That means you have instantiated your class and you're accessing the member function of your class. Now back to the role of access specifiers. We have specified the access specifier here as public. So as said, the accessibility will be within the class as well as outside of your class. So this data member A is used inside your class, or you have the member function that is included inside your class. I am accessing the same outside of my class. Main is outside of your class. I am accessing the display function outside of the class through this object obj. The same way you have used the display function, you can access your data member also. So how do you access? Use the object name. So obj, use the dot operator, specify the element of the class that you are trying to access. So this will give your output as 10 because you have initialized the same through the display function. You have invoked your display function and then you're making use of the variable A. So you are accessing the elements both inside the class as well as outside of your class. So public access specifier gives accessibility within the class as well as outside of the class. Now let's make changes. Let's see how private access specifier is going to bring changes to your program. So let me make this as private. So use the keyword private. Again, use the colon. So whatever attributes that comes below this will be private. So I have made both my data member as well as the member function as private. So if the access specifier is private, the accessibility is only within the class. You cannot access them outside of your class. Let's verify this. So I'm using the same object here. Now let me call the display function obj.display. So I'm trying to access this display function outside of my class. Let's build and run and see what is going to happen. My program doesn't work fine. I'm ending up with error. So what is the error message? Line number 7, void test display is private. That means you're posing some restriction to the accessibility of your data. The display function was private here. So as said, the private members, you cannot access it outside of the class. So when I call obj.display, I'm trying to access the display function from outside of my class, which is not permitted because the access specifier is private. Now you can have multiple access specifiers within the class. Suppose you want to keep data member as private, and if you want to make the member function as public, you can do the same. Just specify public here. Now A remains private and the display function, the member function is public. So now this error should be fixed because my display function is public because I have used the access specifier public here. So public access specifier allows the member to be accessed within the class as well as outside of the class. Let's verify. You can build and run. Now your program works fine. You can see A equal to 10. It's because you have changed the access specifier private to public for the member function. So it is allowing you to access the data outside of your class as well. So using access specifiers, I'm abstracting my class. I'm posing some restrictions to the accessibility of the elements of the class. So this is how you create your class, you instantiate your class. Moving on with the OOP concept, polymorphism. The word polymorphism means having many forms. Technically, single interface, multiple implementations. Real life example of polymorphism. A person at the same time can have different characteristics, like a woman at the same time is a mother, a wife, an employee, etc. So the same person possesses different behavior in different situations. This is called polymorphism. In C++, two types are there, compile time and runtime polymorphism. Inheritance. Inheritance. From the very word meaning you can make out, that is, you are acquiring something or some properties from your ancestors. The capability of a class to derive properties and characteristics from another class is inheritance. Inheritance is one of the most important features of object-oriented programming language. So you can look at these features as the pillars of an object-oriented programming language.